with that, we move on to the next presenter who has been hiding out there in the back for a while. James Sankar, he's project manager of UKERNA, the British NRAN. He is there responsible for a number of projects that, according to the information, still uses the political incorrect term last mile technology, but I'm sure they will shortly change it to first mile to show that they really reach out to the users. And apart from that, James is also active as co-chair of the Trainer Task Force Mobility, and he will now tell us all about the last mile technologies that UKERNA trials.
Thanks, Klaus. Okay, yep. I'd like to share with you what we've been doing on network access with UKERNA, and especially with the work to actually get network access wide into the JANET network. Okay. Let's see if this works first. That one, okay. Okay, so I'll just briefly explain a bit about the JANET network access area, and then I'd like to go into a bit more detail about the work we've been doing on ADSL, and also the two-way satellite trials which we've got underway at the moment. Then I'd briefly like to discuss about our newer area, which we're actually putting quite a lot of resource into, which is the wireless area, other network access technologies, and then take a sort of like step aside from the technology and look at the issue of users and technology as well. Users and, relevance to European NRENs. So as Klaus has pointed out, I've used last mile there, and there's very, very many different terms to describe network access. But essentially what we're talking about here is the network between you, whether that's you as a laptop user, let's say, and your local exchange, hub or base station. So, for example, with ADSL, you would connect your local exchange, and from there to maybe your core network via an ISP, for example, and so on for hub and base station, etc. So, why network access? Well, in December 2000, we realized that although we've been doing quite a lot of work in developing the core network, which was actually upgraded recently to 10 gig, we needed to also consider how we could widen access to our users. And the way we did that was by creating a network access area within the network development team. Why did we do it? Well, because a lot more people these days don't really want to work or study from a laboratory environment these days. They want to work and study from home. There's more distance learning. People like to be in a more convenient learning environment. Coupled with that, we also see that a lot of the local loop provision has changed. There is many more providers out there offering many more different types of solutions. So the result is that we need to look at different ways in which we can provide broadband activity to our users. Recently, and they've just added this slide in the last few days, we actually got a paper put together on how we were going to approach this area, and also to just reaffirm how we were going to improve network access. And I think these are fairly self-explanatory, but there's two sort of approaches to dealing with it. One is to develop network access technologies that would directly connect to the core network, and we did that with ADSL. The other option is to actually use the services of, let's say, a technology provider in, say, two-way satellite, and have a connection to the internet, which would then peer back to our core network. That's one approach to offering more network access solutions. The other area is to turn it on its head and say, why don't we look at what services we can provide at the edge or at the core that could support network access users? So maybe we could think about putting some sort of AAA or authentication solution in place so that it would make it easier for users that had network access services that were, as there are many of them, say ADSL again, cable modem, etc., that would actually not have the issue of having to configure their network access solutions, and they would be able to get access into JANET much quicker. And we have, as you can see on there, a URL to actually look in more detail at that particular paper. So I'd just like to go straight into a couple of the projects that we've been working on. ADSL is the key one that we're actually close to completing now. And I'm sure most of you are aware of ADSL. As far as the UK is concerned, there's a number of strengths with ADSL. There's a number of weaknesses with it. But we chose this one first of all because of two reasons, really. The first is that it was a novel technology back in December 2000. Or should I say it was at the bottom end of the S-curve. There wasn't that many commercial providers out there. The technology was still a bit expensive. Not many people were using it. However, it was also a technology that could be used cost-effectively to actually connect different campuses, different scattered pieces of campus to, say, your main campus, or maybe to, say, your regional network, or directly to JANET. So you've got the opportunity to actually trial a technology that's fairly new, but that could make a big difference to teaching and learning. So we went about trialling this service, and how did we do that? Well, we actually got in touch with BT Wholesale at the time, who were the only providers of the service. And we started working with them on a trial. And we actually purchased a direct connection between the BT network and the JANET network. And that was back in December 2001. We actually got our off-campus learning centres connected in May 2002. And this is the way in which we did it. As I say, there was a 155 megabit connection between the JANET network, which had a radius server in place to authenticate users. That went back to the BTIP network, and then from there it went through local exchange back to the end user, who was normally at one of these off-campuses on the site there. And what did we find? Well, we found that the routers that the telco provided were quite restrictive. So, I mean, what you find now, actually, in hindsight, is that people tend to go for wires only. They don't want to actually go about getting a BT router that's been pre-configured. A lot of people just want the wires only connection. They can get their own router, they can configure it the way they like. And that's also led to the development of these wireless routers as well, which are a combination of 802.11 and DSL. We did do some trials with VPN over ADSL, but the problem we had was that from a very early stage we'd set the parameters for the service to be NAT for security purposes. However, this tended to cause a large number of problems in terms of configuring between both of the end sites. It can be done, but we weren't able to achieve it with the trial site that was working with us. As we see at the end there, we were actually ending the trial in May. We did actually try to consider the option of going towards a full service, but to be honest, the commercial environment in the UK has changed significantly. Prices have come down. There's more ADSL, SDSL, VDSL products around, and to be honest, we think that it would be better if the commercial providers actually took this service and offered it to the JANET community. So quickly about two-way satellite. Features, but it speaks for itself. We just get a satellite dish installed into a remote or rural area that doesn't have any fixed broadband connectivity, and we can provide a connection to and from the internet. The strength of this is that we can reach the whole of the UK. The downside of it is that it's expensive, there can be latency issues, and depending on the type of connection you get, you can have contention on there, which isn't very good for, I suppose, trying to do more novel services or support over the satellite. So what we did is that we went out to tender. We tried to get bids from all of the satellite service providers, and in the end, we actually went to choose SES Astra and Satlinks. And the reason why we chose these two initially was that SES Astra was providing a service that would be more suitable for, I guess, connecting up the off-campus learning centres, whereas the GILAT system, which is a much cheaper and cheerful system, is really there to support individual users or groups of users. However, when we actually came to implementing the solutions, we found that we couldn't get the kind of connectivity from the Satlink services that we would have liked in the Cornwall area. So as a result, we actually contacted another supplier, Bridge Broadband, who was able to provide us with a Hughes Network Systems Europe solution. And this was particularly unique because it was going to be one that would support up to 150 PCs. So this one's quite an interesting one that we've just brought on board recently. And this is the sort of slide here that's showing you where we're doing this activity at the moment. The key areas of interest here are, if you're looking towards Scotland, you've got a cloud there as a virtual private network. We've actually got 5 sites connected to the UHI sites there, and they're all working successfully. However, we're also going to increase that to 7 because it's been so good, really. So we're very pleased with the work that's been done there by the team at UHI. We've also got several GILAT systems in place, which I'll come on to later, and they're really for individual users, as I say. And there's a bridge broadband service there, which is catering for the larger number of PCs. So, yes, we could have gone for a GILAT service in Cornwall, which is on there, but the thing is we actually wanted a service that could support a bigger campus. This is just a view of the network topology. As you can see at the ground station end, we haven't got a direct connection to JANET. And the main reason for this is that the cost to actually get the connection from Europe across to JANET was actually more expensive than the actual cost of the project altogether. Okay, just to explain here, we chose these 2 different types of technologies, and it's really a case of you pay for what you get. So with GILAT, you're using just the Q band for both your transmit and receive, but it's much cheaper and it's suitable for a very small number of users. The downside is that you're not able to offer VPN over it, so if you just wanted sort of email, web browsing type facilities, then it's fine. If you wanted one that could do a lot more, then you would need to look at something like the Astra one that we show here, which is using the Car band and the Q band. So where are we now? Well, we're actually producing statistics on the performance of both of these platforms. That's the BBI one and the GILAT, and that's actually on our website at the moment. And we've got statistics from February, March, and April, and we'll be putting the ones up for May shortly. So please do have a look at that if you can. We've also got Cornwall College on board, and their Hughes network system actually went live last week. So I'm just waiting for an update to see if it's all working properly. Here's an example of the satellite results that we've got. Okay, so this is the Astra BBI. This is the first month of operation. If you look at the maximum BBI throughput, round trip times, you can see that there's quite a lot of large peaks there. I mean, you're looking at in excess of 3,000 milliseconds. So when we actually looked further into this, we realized from our suppliers that the problem actually wasn't the satellite link. It was a network connectivity from the ground station back to the internet that was the problem. And in several cases, the ATM links had failed, either at London or at Betzdorf. But overall, you're looking at around about 6 to say 900 milliseconds there on average. The other thing to point out with the blue charts at the bottom, they're sites that didn't ping. So although it looks fairly reasonable, it isn't really that stable at the moment, and we're having to work quite hard to try and get that improved. Whereas GILAT, well, as I said earlier, you pay for what you get, and with GILAT it's way off the scale there. It's over 3,000 milliseconds. And one of the main reasons for that is that when a packet actually goes around the network, if it collides with another packet, what happens is it goes back around the network until that packet can actually get through, which is why the throughput levels there are absolutely crazy. The result from the user experience is that with GILAT, you're able to download very, very well, as there's no problems with that. But if you're trying to upload, so if you're trying to send email or FTP, it's horrendous. And many of our users have actually had to revert to ISDN during this trial if they needed to get particular applications running. So GILAT has got a long way to go. And also with GILAT, there's something like 28 hops between the ground station and actually getting a connection to the internet and back to us if we're doing a round-trip test. So it's not been very good at all. So that's very, very quickly how those two sort of projects are at the moment. The ADSL project is ended, or is near to ending at the moment, whereas the satellite project has still got a good 10 months to run. So we really do hope that we can make some improvement in the performance of the GILAT system. So by all means, please see the results for that. Okay, the other area we're looking at the moment is the UKERNA wireless access area. Again, we've produced a network survey, and this is a survey of all of the UK academic institutions and what they're doing in both fixed and mobile areas. And what we've done is we've gathered a team of people who responded to that survey to form a wireless advisory group. Now, this advisory group will be looking at all the technologies that we have at the moment, fixed and wireless, and we'll be having a meeting at the end of this month to try and develop a roadmap for where we would like to go for wireless, what technologies we would like to trial, and also looking at what architecture we would like to have in place to support wireless activities, I guess at the national level, which a lot of the other NRENs like DFN and SurfNet are already doing. So it should be an interesting time, and we can also learn from the other NRENs about their activities. And again, with the Mobility Task Force, we've learnt a tremendous amount about what's going on, and I suppose we can try and learn from their lessons as well. Other network access areas. This is a list of the other areas that we are tracking, and if it is appropriate, we will be doing trials in these areas as well. IP over power is quite an interesting one. This has been developed by SSE Telecom, which is in Scotland. They have set up a number of trials in the Scottish area where the users can are actually given a box which they just plug straight into their power socket, and they'll get their internet connectivity. We've seen some early results from this trial, but personally, I would say that I don't know whether that would scale. It's been working well in small communities, and it would probably work well in student residences or places that are difficult to cable, older buildings maybe. But again, you've got wireless there, so you know maybe with IP over power, it may boil down to just how easy it is to implement. So that's one area that we're looking into. The others there are fairly sort of standard: cable modem, fibre to the home. There's Pirelli, who's interested in working with us to develop some fibre solutions, mesh radio, and also there's the element here of mobile 3G, UMTS, because in the UK now we have the company called 3, who have developed the 3G network, and I'm very keen to get involved in some sort of early trials of the technology, just to get some user experience of how good it is and what happens in certain scenarios and environments, and what are the applications and what can they do, and how can they be of benefit to the academic community. So there's quite a lot of activities there. Okay, technology aside, users. One thing that I've noticed in my 18 months of working in the academic environment is that a lot of the technology is about connecting what we've already got issues with, whether it's scattered pieces of campus, student residences, small groups of users. It's fairly manageable, it's scalable, everybody knows the parameters, and that's what everyone seems to be focusing on. But what about those people who are the students and other staff? You're talking about thousands, not tens or hundreds. What about providing a network access solution that's going to be there for them? And I sometimes think that we're so concerned with how we actually connect up, say, our staff, that we haven't even thought about considering students, because there's a whole minefield of issues to overcome, whether it be acceptable use, whether it be content filtering issues, because if you're having a connection at home, how do you know whether it's going to be accessed by somebody that's maybe under 16? AAA security issues are another thing if you've got students to deal with. And I guess it's a less stable user base than the one we know. So it's something that we need to we need to consider how are we going to support students, how are we going to support other staff in the future as far as network access is concerned. The other area that I guess I've learnt about in the last year or so is working with other NRENs through Terrainer. I'm completely in agreement that we should be working together. We should be learning from each other's activities. We shouldn't have to reinvent the wheel. And making use of the mailing list and exchanging our results and documentation should be something that we should be encouraged and we should continue to do. And with my experiences on the mobility group, I would welcome more participation and contribution from all of the NRENs. I've put a list there of the examples of the task forces that my colleagues mentioned to me. But I must say, I think that if we all want to improve the way we work and get these solutions in place, we should work together more. Okay, to summarise, UK network access. There's many technologies. Pricing is becoming more competitive, and that's why there's a lot more in terms of broadband users in the last 12 months than there's been, I think, since broadband took off. But in the UK especially, there's no single technology that meets everybody's needs. We've probably got about 60% of the UK covered by fixed broadband links. But what about the 35%? And these are normally termed as rural broadband users. What happens to them? Who supports them? Who offers them a universal service so that they can actually get access to education and teaching materials? It's something that we need to address. Also, there may need to be a mix of technologies because everybody's needs are different. So we need to consider that as well and how we interoperate between the different solutions. We have to consider the users, their needs, security. I mean, the list goes on. Bandwidth, contention, which is not normally something that the telcos like to mention. Also, latency and cost issues. A key area will be location-independent networking. That is providing the support and architecture to make the user able to actually get access to the network, or whether that be their institutional network or the NREN network, so they can get access to the services they need, whether they're on the road, whether they're in their homes, whether they're at work, etc. That's an area that is going to be key. And also, NREN collaboration will be invaluable in bringing these things together and solving the solutions. So where do we see the future? AAA issues. We need to resolve AAA issues, and that's something that the mobility group are doing. Again, we also need to sort out the whole aspect of location-independent networking, which some of the NRENs have done. I also see there'll be more network access cards that actually support wired and wireless. You'll be getting DSL, you'll be getting 802.11 and GPRS, UMTS combined cards. And I think that's something that will be coming out, and it's already out there, but there'll be even more of it in the next 6 months or so. We need to solve the issue of rural broadband connectivity as well and offer similarly priced solutions across the board. We also need to look at solutions for individual users. So we need to consider network access for staff, but we also need to consider our students as well. Thank you.
Thank you, James. Are there any questions? Was it that clear? Good. I have one question then. You were mentioning that the two-way satellite system perhaps doesn't perform so well under extreme weather conditions. My first thought was that is almost always in the UK. But to expand on that a bit, we have done a test with free space laser, and we basically just dropped that because it rains too much in the Netherlands. And so I'm curious to see if you have done any tests on that, how the performance drops when it heavily rains or things like that.
Yes, at UKERNA we're actually on the hills, on Chiltern Hills. And when it rains, it rains, it really rains. I mean, but when it does, we had a thunderstorm. I remember we just put the connection in, and we had a thunderstorm. And the first thing I thought was, satellite connection, let me see how it's running. And I went into there and I switched the monitor on, and there was nothing. Not a connection at all. And we had that happening for about 15 minutes. So we had no network connectivity at all. And consequently, later in the day, the storm actually went over towards Betzdorf, and we lost connectivity again, because that's where the ground station is as well. So I think that's a key problem with two-way satellite. But if it's the only connection that you can take, because there's no fixed solution available and there's no wireless, it's better than nothing, I suppose. But yeah, we'll see.
Yeah, so basically the conclusion is don't do two-way satellites unless you have no other option.
Unless you have to, okay. I guess. But that's part of the trial, to see these things.
Okay, thanks again, James.
Okay, thank you.
Okay, then we go to our third and last speaker of the afternoon, Coletta Elisa Marchioro from Torino. She works with the company/research institute called CSP. She knows basically everything about mobile networks and voice over IP, and she's going to share her experiences with that with us. So, are we ready? Okay, over to you.
All right.